All right, let's look at amortizing pragmatic program synthesis with rankings. What is program synthesis? In program synthesis, the system maintains a space of programs. The user gives an example, and the system returns a program that is from the space and consistent with the example. For example, suppose the space is all possible arithmetic expressions. The user gives an example that 2 goes to 4. Then the system might return with a program that's 2 times x, which map 2 to 4. An issue of program synthesis, which is a classic problem of synthesis, is ambiguity. Here are some alternative programs that also map 2 to 4, but is unlikely to be the one that the user is intended. And this shows up in all sorts of programming by example situations, where you have a program that's literally correct, but unintuitive. Prior work has resolved ambiguity with rational speech acts. Rational speech acts by Frank and Goodman is a set of recursive Bayesian equations, and once you implement rational speech act into a program synthesizer, you're going to end up with a program synthesizer that not only return you a program that is consistent with the example, but also more likely to be the one that the user has in mind. The issue with implementing rational speech acts in program synthesis is that being recursive and Bayesian, it does a lot of normalization and is very slow. In this work, we seek an alternative synthesizer that simply rank the space of programs. And hopefully, this ranking can match the performance of performing the recursive Bayesian reasoning of rational speech acts. The key research question is, does such an order even exist? Can you represent the complexity of the recursive Bayesian equation using a simple ranking of all the programs? Here are the results. We have proven that in the case of using a single example, this approximation is in fact perfect. And we have empirical results that states that in the case of using multiple examples, this approximation comes very close in practice. And as a consequence, we are able to reduce a cubic time algorithm into a linear time one, and on the actual program synthesis domain considered in prior work, we receive orders of magnitudes of speed up. So now, of course, I left out a lot of details. If you want to find out about these things, please come to my poster. And if you're not going to be at icml, please reach me on Twitter and we'll have a chat. Thank you very much.